In chapter 3, we're going to talk about choices, and we're going to talk about how when things are scarce, and whether that's time or resources or capital or labor, then there have to be trade-offs made. And so we're going to look at this question looking specifically at labor. And so when we talk about labor, all we mean is work. How many hours, how much effort is put into a job uh, by a worker, right? And we think of labor as an input in the production of goods and services. And later on, we'll talk about things like capital, things like technology, which combine with labor in order to produce those goods and services. And then we'll think about new technology, right? And we'll think about how that raises the productivity of labor and increases living standards. As we saw in chapter 1 and 2, the amount of production per hour worked has increased dramatically over the last 200 years. And then one of the questions that we could ask is how that increase in productivity affects how much people work, right? You could say, oh, well, I can produce so much with every extra hour, I should work as much as possible. Or you could say, oh, I can produce so much with every extra hour that I don't need to work that much. And from a theoretical standpoint, either of those solutions is possible. And so we need to look at the data. And as we see in the data, so this is just 3 countries looking at annual hours worked here on the vertical axis and GDP per capita on the horizontal axis. And you can see back around the turn of the 20th century, around 1900, all the countries had a GDP per capita of sort of $1,500 to $2,000 per person per year, and worked, at least 3,000 hours per year. And as GDP per capita increased, the amount of annual hours worked per worker has fallen in all 3 countries, although we see in the US that we're a bit of an outlier. And so if you look at the amount of hours worked in the United States, we're still around 2,000, even though we have a higher GDP per capita, whereas France and the Netherlands are more around 1,400. And a lot of that has to do with a somewhat smaller work week in those 2 countries, but also a lot more vacation time for those workers. And so those are some cultural differences, some institutional differences, and we'll talk about those as we go along. The other way we can look at this is not in terms of hours worked, but in terms of average annual hours of free time per worker, again, looking at GDP per capita. Um, and what we can see is that there is definitely a clear relationship. So Norway is up here with the highest GDP per capita and one of the highest annual hours of free time, along with the Netherlands, Denmark, Germany. The US, we can see, is a bit of an outlier in terms of where we would expect the amount of free time to be. We might expect them to be a little bit more over here, but not too much of an outlier, right? We're still sort of in that general range, and Mexico is down here with the lowest GDP per capita in this group of countries and the fewest hours of free time per worker. And so what we want to do in this chapter is really think of a model of individual choice, whereas in chapter 4 we'll think about how choices of different people affect each other. Here we're really thinking about individual choice. And so the way we're going to start thinking about this is with grades and study hours. And so we'll think of a production function where the more you study, the higher grade you get. And what we see is that this does seem to be brought out in the data. And so if you're thinking, oh gosh, I'd like to get a really high grade in this class, then the best thing to do is to study. But one thing that the data do tell us is that it's important that you have a good environment instead of a poor environment when you're studying. So you need to be able to set a time where you're not going to be distracted, don't have the TV on, don't have people around you who are talking. But then if we control for the study environment, we see that going from a low study time to a high study time does increase GPA. And so if we're thinking about this, we can think about a production function. So these are just made up numbers. But what we have are an input, in this case study hours, so the number of hours we study, and an output in terms of grade on the final exam. And so if we study 0 hours, then we get a 0. If we study 1 hour, then we get a 20. 2 hours, we get a 33. 7 hours, we get a 69. 11 hours, we get an 84. Okay? And so this is our production function for final exam grade with just one input, the amount of hours studied per day. In our case, we say, all right, well, the most you can get is a 90 in this final exam if you study 15 hours. And if you study any more, you still just get a 90. So there's no point in studying more after that, as we'll see. What can we tell from this production function? Well, one thing is this idea of marginal product. And whenever you hear the word marginal, just think of one more. And so what we mean here in terms of marginal product is how much the grade changes due to one more hour of studying, right? And that's going to be the slope of the production function. Well, the slope of the production function, well, the production function is a curved line, so we would actually need some calculus in order to get the actual marginal product at each particular point. But what we can really tell is how much the grade changes for each additional hour of study. So for instance, at 4 hours of studying, we get a 50 on the final exam. At 5 hours of studying, we get a 57. So the marginal product of that one additional hour of studying is 7. If we study 10 hours, then we get an 81. And if we study 11 hours, we get an 84. So up here, the marginal product of one extra study hour is only 3, right? 84 to 81. So what you can see is that the marginal product is actually getting smaller. We can also see the average product. The average product is the slope of a line going from the origin at 0, 0 to whichever point we're interested in. So at 4 hours of study, 50 divided by 4, just the rise over the run, is 12.5, right? 50 divided by 4 is 12.5. At 5, it would be 57 divided by 5, so that would be 11.4. The average product at 10 hours is the slope of this line, which is just the rise, which is 81, divided by the run, which is 10. So that's 8.1. And so just like the marginal product, you can see that the average product is also falling. And we can graph these two curves. So the average product here is the red line, the marginal product is the blue line. And what you can see is that, they start off at the same point because that first hour gives you a 20. 20 divided by 1 is 20. So they're both here. The second hour gives you 13, right? And so that's this point here, 13. The third hour gives you 9, going from 42 to 33. The fourth hour gives you 8. The fifth hour gives you 7. And so you can see the blue line falling. And that's this idea of diminishing marginal product. Each extra hour of studying gives us a higher grade, at least until we get to 15, but at a smaller and smaller piece, right? That marginal product is getting smaller and smaller and eventually goes to 0 here. The average product is also falling, and that makes sense because if the marginal product is falling, then the average product must be falling as well, because we're adding that smaller bit to each average. And so you can see here at 2, 33 divided by 2 is 16.5. That would be here. 42 divided by 3 would be 14. That's this point here. And so the average product is also falling. You can see that once the marginal product gets to 0, it just stays flat, right? It just doesn't get any, it doesn't change. But the average product is still falling because you're adding 0 marginal benefit to each extra hour. And so this is something common that we'll see with production functions is that we'll sort of assume diminishing marginal product, which will mean that the average product is falling as well.